All right, folks, here we go. So, just recorded the video and didn't have the correct thing plugged in, so 17 minutes of my life gone. All right, so hopefully I've got it right this time. So we're working on, again, a review of algebra. First thing we want to take a look at here is prime numbers. Prime number is any number, whole number, greater than 1, whose factors are 1 in itself. So when I ask students this question, they like to start with the easy ones, like 2, 3, 5, obviously 17. We can do that, 37. Those are prime numbers. Next example or definition here is a composite number. Any whole number greater than 1 that has 2 or more factors. So any example that you want to throw in here, 4, 12, a couple of examples of composite numbers. So next thing you want to take a look at is when 2 or more numbers are multiplied, each of the numbers is a factor. So for example, the number 12, 1 times 12, 2 times 6, 3 times 4, those are all factors. Those are all factors here. So next slide I want to take a look at is factor each number and classify as prime or composite. So we have the number 22. You have 1 times 22, but yes, it's even, so it can be broken down 2 times 11. That is a composite number. The number 31 is only 1 times 31. That makes it a prime number. That is a prime number. All right, so the next slide here, we're going to go to what is prime factorization, a definition here for it. Prime factorization was when you take a number and you express it as a product of all prime numbers. I like to start by making a factor tree, and then you write down them all out and keep it in kind of an organized fashion. So that one's kind of a big number, so I'm going to go back to this slide, this page here, and do a couple easy ones for you, get you started here. So let's start with the number 12. So if I break down the number 12, what numbers multiply to give you 12? So for example, you can go different ways, but 2 times 6. 2 is a prime number, so I circle it, and 6 is 2 times 3, so I'll circle that as well. So that's the tree set up there, and then writing out 2 times 2 times 3. So that's called the prime factorization, writing it out as a product of primes. Now we're going to go to the next page here, and this one's a little bit lengthier, so that's why I wanted to start you out with an easy one. But first thing I recognize with this big number right here is that we have a negative. So whenever you have that negative 132, you want to start out by breaking it down to a negative 1 and a 132. That's a nice way to remember that you have a negative number. Next, we want to take that 132, and again, if you go, I have no idea what multiplies to give you this number. First thing I always think about is it even? Yes, this is an even number, so always take out a 2. 2 times 66 here. Now you can break down the number 66 however you want. So 2 times 33, break down the number 33 times 3 times 11, and those are all now prime numbers. So to write the prime factorization for this, I would start with negative 1, and then include all the numbers that are circled. 2 times 2 times 3 times 11. And so those are the numbers. Now don't forget about the variables. I don't always throw the variables in with the tree. But remember, we have x squared, so that's x times x, and then y to the third y times y times y. So that is truly the prime factorization of negative 132x squared y to the third. So now we want to go to what is the prime factorization here of 84, and then I'm going to do 30. So let me go with 84 over here. Again, you can break it down however you want. So what's easy for me is 4 and 21. Are either of these prime numbers? Nope, they are not. So I have to break down 4 to 2 times 2. I have to break down 21, 7 times 3. And now I have my prime factorization. So I know that 84 is 2 times 2 times 3 times 7. Next, I want to break down the number 30. Most people probably go with the 6 times 5. 5 is a prime factor, and then 3 times 2. So writing this out, I have 2 times 3 times 5. So once that part is done, what I want to do from there is let's circle what is common between both of them. So what's common here is the 2, and what's common here is the 3. So in taking a look at what is common, 2 times 3, so that is 6. So this right here, part C said, what is the largest number that is a factor of both those? That was 6, and that is called the greatest common factor, the GCF. GCF, and that'll lead us into the next slide. So on the next slide, definition here, what is the greatest common factor? Is the greatest number and or variables that is a factor of the given numbers. So again, we write down the prime factorization, circle what's common, and we go from there to find the greatest common factor. So let's take a look at the number 12 and the number 18. 2 times 6, 2 times 3. So when I write out 12, 2 times 2 times 3. Next I look at 18, 2 times 9. Break that down, 3 times 3. So when I break down 18, it's 2 times 3 times 3. And then I want to finish with what is common between both. So again, in this case, 2 times 3, 6 is my greatest common factor. And just because the two examples that I gave you were 6 does not mean that every single one of these that we do, the greatest common factor is 6. In this case right here, we want to review the distributive property before I get to that part, but I just wanted to show you that. So the distributive property is when you have a term or expression on the outside and you multiply it by everything that's inside of parentheses. So 5x times 3 is 15x. And then we go to the next term, 5x times 5x is 25x squared. And so now we're going to show you how we go in the opposite direction with some definitions and expressions here, and then we'll get some examples on the next page. So the first thing you're going to do is find the greatest common factor. You write it on the outside of the parentheses, and then you take out that, and whatever is left goes inside the parentheses. So let's walk you through a couple of these. The first one is the one that was on the previous page. This is how I would start that. So 15 I would break down to 3 times 5. Circle these. So 3 times 5 times x. For 25x squared, I think I can fit that in right here. So 5 times 5. So that is 5 times 5. This is a 3, by the way. Times x times x. So what's common between these? I can see that a 5 is common, and we have an x that is common. So whatever is common, let's put that on the outside. So 5x is on the outside. What is left on the inside is a 3. 3 from here, and then over here is a 5x. So you put a plus there because there wasn't a minus, so plus 5x. So this right here is the factored expression. And if you go back to the previous slide, you would see that's what we started with. So let's go to number 6 here. So for number 6, we break down 4x into 2 times 2. So we have 2 times 2 times x. Let's break down the number 32 over here. 2 times 16, 2 times 8, 2 times 4, and 2 times 2. So a lot of 2's here. So there's 5 of them. 1, 2, 3, 4, 5. So that's breaking down the number 32. And oh, I already forgot. Notice that there was a minus there. So this actually should have been a negative 32, and I should have had a negative 1. And if you forget that, then yes, you will get that wrong. So where am I going to put what's common, or let's circle what's common here. We have a set of 2's and another set of 2's. So I'm actually going to go above here. So 2 times 2 is 4. 4 is on the outside. What is left that is uncircled goes on the inside. So right here, this is an x. Go back here to the negative 1. So there's a negative. We have a 2 times 2 is 4 times 2 is 8. So final answer here, without hitting the top of the screen, 4 parentheses x minus 8. And hopefully you know there is a way to check all these. We can redistribute. And if I redistribute here, this is 4x, and that's minus a 32. So that's a way that you can check to make sure that you're doing these right. This next question I'm going to have to do below here because I don't really have a lot of room. So I'm going to take that 12, And I'm going to break down 12. Again, 2 times 6 and 2 times 3. Get a little bit more room here. So when I write this, I have 2 times 2 times 3 times a times a. Let's break down the number 16. 16, 2 times 8. 8, 2 times 4. 4, 2 times 2. So what we have here is 2 times 2 times 2 times 2. And we have an a. So let's circle what is common here. 2, 2, and an a. So let's finish that off with 2 times 2 is 4. A is outside the parentheses. Inside is what is we did not circle, so 3a. We don't have that minus, so that's a plus. And then we're left with the 2 times 2, which is 4. And I'm going to let you do the last one there on your own. Number 8, so I'm going to roll right into number 9 here. So number 9 says we have 2a in parentheses, 6a plus 8. Why is that not in factored form where this one is? Well, hopefully what you realize is in the first part here, these are both even numbers. So you can still take out another 2, and so therefore they did not take out the greatest common factor. The greatest common factor is 4a. So they didn't go far enough, you know, with what needed to be taken out. So what we're doing now here is we're going to go in reverse, or we're going to go to well, we're going to finish up with summary here, and then let's do the last one here together, or let me try to figure this one out here for you. So let's take a look at 18. Let's break down 18. 2 times 9, 3 times 3. So when I write the prime factorization of this, 2 times 3 times 3 times x times y times y. Let's break down the number to negative 24, so don't forget about that negative 1. So negative 1 times 24. And again, 24, I'm going to go 2 times 12. 12 is, let's see here, whatever you want. Let me get a little room here. 2 times 6. 6, 2 times 3. So the prime factorization of the negative 24, so we have negative 1. We have 2 times 2 times 2. I think we have 3 of them there, times 3. We have x times x, and we have a y. So in terms of the prime factorization here, circle what is common. I see a 2. I see a 3. I see an x here, and I see a y at the end. So let's put those together. 2 times 3 is 6. We have an x. We have a y. What is not in parentheses is 3y. Over here we have a negative 1, so we want to put that in. 2 times 2 is 4. And then this right here is an x. So that would give us the number broken down into prime factorization, and then we factored it out. So again, great job with notes, folks.